The asset properties in database management systems, DBMS, ensure that database transactions are processed reliably. ACID stands for atomicity, consistency, isolation, and durability. Each property plays a critical role in maintaining the integrity and reliability of a database. Let's discuss each with examples. 1. Atomicity. Atomicity means that a transaction should be treated as a single, indivisible unit. Either all its operations are completed successfully, or none are. If any part of a transaction fails, the entire transaction fails, and the database remains unchanged. Example: suppose you are transferring $100 from account A to account B. The transaction involves 2 steps. 1. Deduct $100 from account A. 2. Add $100 to account B. If the first step succeeds but the second step fails due to a system crash, the entire transaction should be rolled back. Account A should not lose $100 unless account B gains $100, maintaining consistency. 2. Consistency. Consistency ensures that a transaction brings the database from one valid state to another valid state, maintaining the integrity of the database. It ensures that any transaction will bring the database from one consistent state to another. Example: consider a banking system where the total balance of account A and account B should remain $1,000. Before a transaction, account A, $700. Account B, $300. Total, $1,000. If $100 is transferred from account A to account B. After the transaction, account A, $600. Account B, $400. Total, $1,000. This maintains consistency as the total balance before and after the transaction remains the same. 3. Isolation. Isolation ensures that multiple transactions can occur concurrently without leading to inconsistency. Each transaction should execute as if it is the only one running, even if there are other transactions taking place at the same time. Example: suppose 2 transactions are running concurrently. Transaction 1 reads the balance of account A. Transaction 2 updates the balance of account A. If isolation is not maintained, transaction 1 might read an intermediate, uncommitted balance written by transaction 2, leading to incorrect results. With proper isolation, transaction 1 will either read the balance before or after transaction 2's changes, not during the intermediate state. 4. Durability. Durability means that once a transaction has been committed, it will remain committed even if there is a system crash or power loss. The changes made by the transaction are permanently saved in the database. Example: suppose you complete a transfer of $100 from account A to account B, and the transaction is committed. Even if there is a sudden power failure right after the transaction is completed, the changes will still be reflected in the database when the system restarts. This is because the committed transaction is stored in a non-volatile storage, ensuring the changes are durable. Let's see example of ACID properties. Atomicity. Money transfer between accounts is either complete or not. Consistency. Total account balance remains the same before and after a transaction. Isolation. Transactions appear as if they are executed one by one. Durability. Completed transactions remain even after a crash. Thank you for watching this video. Please subscribe our channel for more videos.